This is page 5 of the Polynomials booklet, example 6, find the fourth roots of -1. That's asking you to solve z to the power of 4 equals -1. We make this into an equation. We've got z to the power of 4 plus 1 equals 0. Now, this is the type where we want to complete the square, but complete the square on the middle term. So I'm just going to work over here for a sec. If you did try and complete the square, if you did, and you had, sorry, no, not complete the square. If you do try and change the plus 1 into a minus I squared, so if you try it this way, z to the power of 4 plus 1 is 0, z to the power of 4 minus I squared is 0, z squared minus I, z squared plus I is 0, then you come across a problem here. Actually, wait a sec. Z minus root I. And we don't want to have our answers in this form, root I. Okay? So this is where we come across a problem here. Because if you're trying to find the roots of that, we don't want square roots of i's, square root of i's. So we don't use that method. Okay? So over here, we're going to complete the square, but on the middle term. So this really is z2 squared plus 1 squared. Now, if that's the a squared plus b squared, the middle term would be 2ab. So this is really z2 squared plus 2 times 1 times z squared is 2z squared plus 1 squared equal, if I add the 2z squared as my middle term, I now have to take it away, minus 2z squared. So this bit here completes the square, putting that equal to 0. Write this as a completed square. It's z squared plus 1 all squared minus 2z squared equals 0. Now, if I write this as a squared minus b squared, it would be z squared plus 1 all squared minus the square root of 2z all squared is 0. So now this is written as a difference of two squares. So now I can continue. So therefore we've got z squared plus 1 minus, so this is a squared minus b squared, z squared plus 1 minus root 2z, bracket z squared plus 1 plus root 2z equals 0. So now I'm just going to rearrange these as z squared, minus root 2z plus 1, z squared plus root 2z plus 1 is 0. Now, these are quadratics, which is why I put the z term second. Now, can't really think of how to factorize those, so we're going to use the quadratic formula for each of these. So we've got z is negative b, which is negative root 2, which is root 2, plus or minus the square root of b squared is root 2 squared, which is 2, minus 4 times a is 1, and c is 1 over 2 times 1, which is 2. Square root of 2 plus or minus 2 minus 4 is negative 2, so plus or minus the square root of negative 2 over 2. So that's for that one, which I'm still not finished. This will be z equals negative b, which is negative root 2 plus or minus the square root of root 2 squared, which is 2 minus 4 times 1 over 2. Again, here we've got z equals negative root 2 plus or minus the square root of negative 2 over 2. Now, continuing with those, I'm going to come over here. So remember, negative 2 is 2i squared. So therefore, z equals root 2 plus or minus the square root of 2i squared over 2. And here, and if we rewrite this square root of negative 2 as 2i squared as well, we've got z is negative root 2 plus or minus the square root of 2i squared over 2. So therefore, we've got z is the square root of 2 plus or minus root 2i over 2, and this one is z equals negative root 2 plus or minus the square root of 2i over 2. And writing these as the roots, the four roots, so therefore we've got, z equals, now we've got root 2 over 2 plus or minus root 2i over 2, And here we've got z equals negative root 2 over 2 plus or minus root 2 I over 2. Now, just one more line. We know that, and we know that, for example, root 2 on 2 is 1 on root 2, so it's 1 on root 2 plus or minus I on root 2. And this is z equals negative 1 on root 2 plus or minus I over root 2 as well. Okay? And therefore they are the 4 roots of negative 1. Now for example 7 on page 5. Factorise z to the power of 6 minus 64 and hence find the values of z for which z to the power of 6 equals 64. So if we start with z to the power of 6 equals 64, then z to the power of 6 minus 64 equals 0. So we're going to write this as a difference of 2 squares. So z cubed squared minus 8 squared equals 0. And we want to complete the square. We can factorise this as z cubed minus 8, z cubed plus 8 equals 0. Then what we can do here, this is z cubed minus 2 cubed, and this is z cubed plus 2 cubed. We can write them as difference and sum of 2 cubes, and then we can factorise those as well. And we've got z minus 2, so factorising the z cubed minus 2 cubed, z squared plus 2z plus 4, and over here we've got z plus 2, z squared minus 2z plus 4, and all of that is equal to 0. So now we need to factorise the z squared plus 2z plus 4 by completing the square, because there are no 2 factors of 4 that add up to 2. So we keep the z minus 2, and we can write this as z squared plus 2z. To complete the square, we go plus 1, minus 1, and write our plus 4 down. Here we've got z plus 2, z squared minus 2z. To complete the square, we go plus 1, minus 1, and then we put our plus 4 down as well. So therefore, z minus 2, we've got, completing the square on those first 3 terms, we've got z plus 1 squared. Now I need double brackets. And minus 1 plus 4 is plus 3. And over here, z plus 2, completing the square on the first 3 terms, z minus 1 squared, again, plus 3 equals 0. So therefore we've got z minus 2. Now I can write this as a difference of 2 squares, both of these, by putting minus 3i squared. Z plus 1 all squared minus 3i squared, which would be root 3i squared. Then I've got z plus 2 times z minus 1 squared, again minus 3i squared, be minus root 3i all squared. I'm putting that equal to 0. So now I can, actually, I won't jump that step. I'll just go minus 3i squared all squared minus 3i squared. Sorry, no squared there. So minus 3i squared. So now I've got z minus 2, z plus 1, so this squared minus root 3i squared, z plus 2 bracket, z minus 1 squared minus root 3i all squared bracket equals 0. So now doing this as a difference of 2 squares, I've got z minus 2, z plus 1 minus root 3i is, because this is of the format a squared minus b squared, is a minus b, a plus b. And I've got z plus 1 plus root 3i. And over here, I've got z plus 2, and I've got z minus 1 minus root 3i, bracket, z minus 1 plus root 3i, and that all equals 0. Okay, so that is the fully factorised form. So now to find the values of z, for which z to the power of 6 equals 64, I have to write it as roots. So writing this now in z minus format, I've got z minus 2, z minus, this would be negative 1 plus root 3i, z minus negative 1 minus root 3i. Then I've got z plus 2, z minus 1 plus root 3i, and z minus 1 minus root 3i equals 0. And so therefore my the roots are z equals, here I've got plus or minus 2, and I've got z is negative 1 plus root 3i, but I've also got negative 1 minus root 3i, so I can go negative 1 plus or minus root 3i. And here I've got 1 plus root 3i, and here I've got 1 minus root 3i. So they're my 6 roots. Okay, that's the end of page 5. Now, if you were to start this by doing a difference of 2 cubes, you would find that you would actually get stuck part of the way and you wouldn't be able to complete it. So best to do the difference of 2 squares at that very beginning. Okay.